All right, so I think this is recording. Let's take a look at solving these two quadratic inequalities. Here in number 11, let's set this equal to 0 and see if we can factor it. And I don't believe that we can. We're looking for two numbers that would multiply together, give us a positive 5, but when added, give us 4. So I don't think that's possible. So let's use the quadratic formula to see if there is a solution to this equation. I'll start by finding the discriminant first, b squared minus 4ac. B squared is 4 squared, which is 16, minus 4 times a, which is 1 times 5, and that's a negative 4. So we do see that there is no real solution to this equation. So what we have here is a parabola that opens upward that is entirely above the x-axis. It does not have any x-intercepts. We're interested in the portion of this parabola that is less than 0. Well, that doesn't exist. The entire parabola is greater than 0, so our final answer is that there is no solution. Let's take a look at this next one. We start out, let's get this greater than or equal to 0. Let's have negative 2x squared minus 16x is greater, oops, I meant to subtract 30 from each side is greater than or equal to 0. So if we ignore the inequality and set this equal to 0 and solve this, well, the first thing I notice that all of these are negative, but also all of these are even numbers. So if I divide everything by a negative 2, that'll get me a leading coefficient that I want. And 0 divided by negative 2 is still 0. So with a leading coefficient of 1, that makes this pretty easy to factor. X plus 5 times x plus 3 will do the trick because 5 times 3 is 15, but 5 plus 3 is 8. So that gives us critical points of negative 5 and negative 3. So our first decision is whether we want to include these values in the solution set or not. We look to the original inequality and we see that it is underlined, that it does say greater than or equal to, and because it has that equal to portion, we make these solid dots. Now the original quadratic had a leading coefficient that was negative, so that would be a parabola that opens downward. And we were interested in that portion of the parabola that is greater than or equal to 0, that is above the x-axis, and that happens, all of these x-coordinates will have y-coordinates that are above the x-axis. So our solution set here for this number 12, written in interval notation, is we have a bracket at negative 5 and a bracket at negative 3. It's a smaller number, comma, a larger number. It's the set of all real numbers that are between negative 5 and negative 3, including the endpoints. All right, so I hope that helps, and I will talk to you later. Bye.